So in the development of surfaces, we will cover cone problem. That if we cover cone, almost all problems we complete, all varieties. That is pyramids, prisms, base cutting type in pyramid and base cutting type in prisms. All we have covered. Now we will cover the cone. So the data for this problem is base diameter is 50 mm. So diameter of the base is 50 mm. Height of the cone is 60 mm. And which is resting on HP with its base on HP. And when it comes to the suction part, suction plane perpendicular to VP and inclined at 50 degrees to HP, bisecting the axis means at its mid height. So you have to take 50 degree, mark a point at the mid height and take 50 degree from the horizontal line, and you have to pass the suction plane. So we will see that. So let me draw the stage 1 for you according to this condition given. So draw an XY line. Draw XY line. The base diameter is 50. So for diameter 50, you draw a circle here below the XY line because the top view is a circle for a cone. So that is why we are drawing a circle here. So find out the center of this. So you will be finding the center. So now after finding the center, draw a horizontal and vertical diameters to it. So if you do like this, you will get 4 compartments. Now further divide this into 4 more. That is at 45 degree you can draw a line and extend that line, and towards this again 45 degree line towards this and extend it. So in total you are dividing the circle into 8 equal parts. Now let me take the letters now A, B, C, D, E, F, G, H, back to A. So there are 8 parts. 1, 2, 3, 4, 5, 6, 7, 8 parts. So now from all these, it is one set of letters here because it is a cone. Cone means normally you will be having like this. This will be an apex point. So you will be marking O over here. Okay, and only one set of letters for this. So now draw vertical lines from all these to the XY line. So you get a points here, and axis line is also merging with C and G. So just rise the height here by an height equal to 60 mm. So just rise it up to 60 mm. That is a visible line because C is visible in this case. So just connect the boundary line. Okay. So now mark this as A dash and this as O dash. O1 dash is here. Okay. Now we will see B. B is here. So this will be B dash. So H dash, H dash, which is at the back side. And similarly, we have a C dash here for the visible and comma G dash for the invisible one. So and D dash here at this point, D dash visible, and F. This will be here, comma F dash is an invisible, and the last one is E dash, which is visible. So you can mark like this sometimes. So we draw a thin lines inside to get a marking easier there. So otherwise also you can transfer like this. So suppose if you want, you can also just have a thin lines drawn. It should be a very thin line. Okay, don't draw a thick line. If you draw a thick line, then your problem will become wrong. Because cone will not have a slant edges like this. Only two generators, slant generators will be there. Okay, so you can just complete like this. Now if I take color thing, I'll represent the thick lines for you. So this is the thick line, which should be boundary, and here this is the boundary. So you can just slightly thicken this also, and the 8 points. So now coming to the section. So coming to the section plane, it is perpendicular to VP and inclined at 50 degrees to the HP, bisecting the axis. Bisecting means you have to take the height. Height in our case is now 60. mm. Mid height is 30. Somewhere like this we get. So the axis point is this now. The axis point is this. From where we have to pass our section plane, but in such a way that it is 50 degrees to the HP, not to the axis. If it is to the axis, we will measure from this side. If it is to the HP, we will measure from this side. So this will become 0 for us. So 0, 10, 20, 30, 40 like that when you go, somewhere here you will get a line. Okay. So at 15, I don't know where it will cut, but let us take a line like this. This will be 50 degree. So when you draw that line, we are getting a section plane which is cutting here. That is well within the B point. So inside the B. Okay. So now number this. When we start numbering from this, you can start numbering from left side. So you don't get any number here. But however, this is passing here. So you have to number here. There are two cutting points that you get. So one is cutting here and the other one. Let me call this as 1. So and give 1 dash here, 1 dash here. So then you move back forward here. So you will get 2 points here. Including axis it is 3, but leaving axis 2 points. So second one 2 dash. So move forward here. There are 2 points. One is visible. So 3 dash. So for this we are not giving now. And then move forward, OE, give it as 4 dash. So next reverse, when you move here, an invisible one, that is your point number F. So call this as 5 dash in the bracket. So move down here, again G was not marked, that is 6 dash in the bracket. So move down here, so it is cutting the base. So I have already told base cutting there will be 2 points. This will be now 7 in the bracket. So only 7 points that you get here. After doing all the markings, you have to find out theta. Theta is small r by capital R into 360. The formula used is 360 degree. So small r is 50 by 2, that is in this case diameter is 50, so half of that is 25. This r is nothing but TL. TL into 360 true length line, that is the generated line. So 25 into TL into 360 in our case will give you 138 degree for this problem. So just I am giving you that the radius is TL. So this is your TL. R is equal to TL. So this TL you will take and calculate. So you will be getting 138 degree. So now let me start development part. So mark a point at a convenient place and call that as O, and draw a horizontal line or any reference line equal to the TL. So TL equal to whatever the distance is there, for that you draw and draw an arc also. When you draw an arc like this, we need to have a theta. Theta is we have calculated 138. So from here you measure 138 and just, so this angle will be equal to 130. You have to ensure that the compartment, the arc that you get is equal to 130. So now this arc of 128 has to be initially divided into 8 equal parts. How do we do this? So there is a method you can take called a trial and error method. This is your A. Suppose I start from here. So I have to start from here until I go back to A. So I have to divide this into 8 equal parts. So approximately you can take 138 divided by 8 and take that as a rough length and start trying it out here. But however, there should be a small adjustment to make this into equal parts. 1, 2, 3, 4, 5, 6, 7, 8. Suppose when you mark, if you don't get 8, so if you left with some portion, then you are wrong. You have to increase or decrease your trial and error compass distance and keep adjusting that. Okay, so that in the final you have to get an exact equal part to that point A. So once if you do that, so we can connect this lines, all should be thin lines. So I am connecting a thin lines to this from O. So how many parts are there? 1, 2, 3, 4, 5, 6, 7, 8. So good. So now name this B, C, D. A is already there. Na? So A, B, C, D, E, F, G, H, back to A. Back to A. So this is back to A. So H back to A. So now 8 equal parts we have done by using a trial and error method. So now we also have to do one thing. When you look at this section 1 and 7, which is with respect to the base or this base cutting. So 1 is here and 7 is somewhere here. Okay. So this is 7, point number 7, which is here. So they are lying on this. So how do we find the distance? There can be one method. So when you drop it down here, so you get a point number 1 here. Na? So just draw a line here from here to here. So this angle you can call it as again a small angle theta. Point number 1 is in between the B and C. So means in between B and C I have to get a point number 1. So point number 1 is here. So just draw a straight line to that point. So this is the small angle that you get. You may call that angle as theta or alpha or whatever it is. So that angle you have to measure, and that angle should be marked between B and C. So here B and C is this angle. So when you mark it here, a small angle you can get a one more line here. So I am drawing that in a colored line here like this. Okay, so that is the angle what we get it here, alpha. Similarly, here 7 is in between H and G. So H and G, this is H and this is G. So in between this, we have to get a one more. Just draw a line from here to here. Call this as maybe beta or any angle. So this angle you have to mark here. So from G or whatever it is. So there from G and H in between, you will be getting to that angle one more line. So this is your point number 1 and this is your point number 7. So means we have marked 1 and 7 on the base. So then you move forward. So 2 is for the OC. So measure this distance for the 2 here. That is your X distance. So OC. So mark it as 2. So move to the thing OD. OD is 3. So OD is 3. So you get a 3 here. So next you move to 4. 4 is this distance. So that is for the OE. So OE is here. So 4 distance. Back here when you move here, point number 5. Point number 5 is for OF. So OF again this distance. This is point number 5. So further you move down. Point number 6. Point number 6 is the distance of X again. So 6, but 6 is on the line G, OG. So OG again you will be getting a one more point here called 6. Already 7 we have marked here earlier. So 1 to 7 all the section points we have marked on the development side now. So now take a pencil and draw a smooth arc to connect all these points. Okay, it will be a smooth curve to join all these things. So this is how you get development now. Which is the interesting part here is, so this portion is the required development. So this is the development piece that you need to develop.